Have you ever stopped to think about the invisible energy that powers pretty much everything in your life? I mean, it's what makes your phone light up, your computer run, your whole world go. But how does it actually get from point A to point B? Well, it's not magic, it's a path, and today we're going to trace it.
Right. So, how does it power your world? It feels instantaneous, almost magical, but it's all about a very specific organized path. And once you see the blueprint for that path, you'll get the design behind everything from a simple flashlight to the entire electrical grid in your house.
The secret is something called a circuit. And honestly, the best way to think about a circuit is as a racetrack for electricity. For our little racers, the electric energy, to move, that track has to be a complete uninterrupted loop. If there's any break in that loop, the race stops cold.
And like any good racetrack, you need a team to make the whole thing happen. In an electrical circuit, there are 4 key players, and you absolutely need every single one of them. So let's meet the crew.
Okay, so it all starts with the battery. That's the starting line, the thing that provides all the power. That power then travels along the wire, which is basically the road itself. It's heading towards the load, say a light bulb. And that's kind of like the pit stop where the energy actually does something useful. And controlling the whole shebang, that's the switch. It's the gate that opens or closes the entire track.
Now, here is the most important rule of this racetrack. You gotta remember this. It is all or nothing. Electricity absolutely needs that complete, unbroken path to flow. If there's a break anywhere at all, the entire race just comes to a dead stop.
And here's that rule in action, plain and simple. When you have a closed circuit, see, the switch is down, the path is complete, and boom, the light turns on, electricity is flowing. But in an open circuit, that switch is up and it creates a gap, a break in the track. The electricity has nowhere to go, so the light stays off. It's as simple as that.
So that brings up a really good question. Can this racetrack be made of just anything? Could the electricity travel through a piece of wood or plastic? Well, it turns out the material the path is made of is incredibly important.
And that's because materials fall into 2 main camps. First, you've got conductors, like copper and other metals. Think of these as wide-open superhighways that let electricity flow with almost no effort. Then you have insulators, like plastic or wood. These are like giant brick walls that blot electricity completely. And that, by the way, is exactly why your cords have metal on the inside and a plastic coating on the outside. Okay, so we have the rules of the road, we have our key players, now we get to the fun part, the design. See, you can build your track with just one single road, or you can build a massive system of highways with lots of different routes. And that choice, well, it changes everything. The first design we're going to look at is called a series circuit, and the name really says it all. All the components are arranged in a series, one right after the other. This creates only one single path for the electricity to follow, just one. So in a series circuit, all those pit stops, let's say they're light bulbs, are on the exact same road. This creates a huge weakness. If just one of those bulbs burns out, it's like a bridge collapsing on the racetrack. The path is broken, the circuit is now open, and guess what? All the other lights go out too. It's exactly like a line of dominoes. If you take one out of the middle, the whole chain reaction just stops dead in its tracks.
But what if you gave the electricity options? What if you gave it choices? Well, that is the genius behind a parallel circuit. Instead of one single road, the track splits into multiple branches, giving the current several different paths it can take.
Now this is a much smarter system. You see how each light bulb is on its own separate branch? So if one of them burns out, that collapsed bridge again, it only closes off one road. The electricity just reroutes itself and takes the other open paths. And the result? The rest of the lights stay on. It's a way more resilient and robust design.
So why do we care about one path versus many paths? Well, because you see the results of these 2 different designs every single day, especially in your own home.
Okay, think about those old holiday lights, the ones that were so frustrating. They were usually wired in series. And that's exactly why one burnt-out bulb could make the entire string go dark. Now, compare that to your house. Your home is wired as one giant parallel circuit. And thank goodness for that. It means when your kitchen light burns out, the TV in the living room stays on.
So really, the crucial point, the big takeaway here is this. The arrangement is everything. It's not enough to just have the right parts. How you connect them determines whether you have a fragile system with a single point of failure or a resilient modern one. One path or many. That choice really does make all the difference.
So now we've figured out the blueprint for the electrical racetrack. But what happens when there are too many cars on the road? I mean, when there's a huge surge of current. How do our circuits protect themselves from that kind of overload? Well, that's where things like circuit breakers come in, but that's a topic for another time.